Okay. Doubly linked list. So far we just saw about singly linked list. There could be some operations being asked in interviews, like how you handle the doubly linked list. Let me just take over the questions. There are a couple of questions coming in the chat. Um, what is it? So many things came. What if the reference node is the last node? If the reference node is the last node, then I guess we can delete that node. Yeah, exactly. So you can just delete that because you cannot copy the next element, right? Next or next, anyway, it's null in a while loop. You just delete that. Just you make that node itself as, you need to handle that one more condition. Just take care of that node itself as a null. Okay. If that node, whatever you need to delete, if you set it to null, right, the previous reference will be pointing to null only. So that is what you need to do. That is what I said. Okay, doubly linked list. So in case of doubly linked list, right, instead of having a single next pointer, you will have a pointer to the pointer which is referring to the previous node also. For example, here, right, the head node is pointing to the next element, next node here, and the next node has a reference which is pointing to its previous node. So there are two pointers here. One is the next pointer as well as the previous pointer. If you see that our earlier class or node struct, right, so we had only one element, one node, which is the next. Now we have two nodes, next and previous. Pointers, it's not nodes, it is just a pointers, means references pointing to a next and pointing to a previous node, and both are assigned to null. Once you create an element, right, you will have a previous node set to null and your next node is also set to null. Next node reference is set to null. So once you start creating or start building this doubly linked list, right, so these pointers you need to take care of. These things will managing this doubly linked list is sometimes a bit difficult because you need to play around with these references or the pointers, and you need to be more careful in that. Whatever I told so far, right, inserting an element, deleting element, all holds good, and all take big of one operation. But only thing is that you need to, at the same time, you need to take care of the previous pointer also. For example, like once you are inserting the element in the beginning, so you create a temp node, right, and the previous pointer and next pointer are pointing to null. So don't do about anything in the previous pointer. Next pointer you point to the head node, and whatever head dot previous which was pointing to null, you point to its previous to the newly created node, and then change this head pointer to here. So this is how you can do it. So the operations I am not going to discuss. It is the same operations what we have done in the linked list. Only thing is that the things you need to take care about the previous pointer. What is the advantage here in case of doubly linked list? Doubly linked list is that in singly linked list you can traverse only in one direction, right, from the head node to the last node, until because you cannot go back in the reverse. That is what we just saw in deleting node reference node given, right, in between, and you cannot traverse back. So you need to copy all the elements and you need to reach till the end. But in doubly linked list you can traverse from any direction, from either from the head to the tail node or tail node to the head node. Any direction you can traverse back. So that is the advantage of the doubly linked list. So that makes things much simpler. But the code wise, right, it is a bit complicated because you need to take care of two references. One is the next reference and the previous reference also. You need to take care of that. Yeah, this is how it looks like. Your struct of the node class, node structor class, right? It looks like this, where you have previous as well as next references, which are assigned to null in the beginning. What all operations you can perform? As I mentioned, like you can perform all the operations we just discussed in singly linked list. All that things can be performed. The only thing is that you need to be more careful about managing both the references. There is another interesting thing in the linked list, like you can have a circular linked list. Okay, where what is a circular is like the last node in this particular linked list, right, is pointing back to the head. So that is how it makes the list to a circular. A circular linked list is used more oftenly in the many data structures, like for example, operation system managing the processes in round robin, right? So it time slash, for example, like initially 10 minutes.
अभी घंटा लगता
Somebody, Murthy Sheikh, can you pause yourself? Please, guys, pause yourself. If you have any questions only, then you can unmute yourself. Please mute. Murthy, you also need to mute. So this is that is like operating system, right? If it is scheduling and scheduling is happening in a round robin fashion, then this circular linked list is being used. What all the operations you can perform? Again, you can perform all the operations here. The thing is that there is no node is pointing to null. Only thing is that it is pointing back to the head reference. So inserting at the beginning, how you can do? Inserting at the beginning. What you can do is like you can create a temp node first. I think I have that. Yeah, I don't have that. You can create a temp node, right? Let's say this is a temp node with some value. What you can do is like you can iterate back to the last node where last, you know, the head reference, right? You can go back to the last node where this particular node you will hit with node.next equal to some value which is nothing but head here. So you can check that node.next is head, right? That means it is a last node. So what you can do is it's next. So means this next. So node.next where it is hitting with the node.next is head, right? So once you get that condition, you terminate that while loop, and what you do, this next, right? You point back to this value, this 10th, the temp node, whatever you created. And this node's next, what you do, right? You point back to the head. So this is how you can delete in the beginning, and the head reference you point back to here. I hope this is understood by you. Because why we need that to go till the last, right? Because we cannot do that until we reach to the last, because we need to adjust this pointer, this pointer which is pointing back to the head node, right? This reference we need to adjust. So that is what we are going back to the last node to adjust this particular one. I mean to say this arrow is there, right? This pointer we need to adjust to back to the newly created node which is being inserted in the beginning. So that is the reason we are going back to the last node. And if you see, right? Yes.
Why can't we approach the same thing like copying that instead of traversing, like which we did?
Yeah, you can still do that. You can still do that. Yeah, you can still do that. Both will take big of n operations. For example, like even copy, right? You need to copy all the element till you reach the last element, right?
No. What I'm saying is only the head node I will copy into the new node. Right, the 2 will be copied into the new node, and whatever new 10 value will be updated with the 2, and then I will just reference head.next equal to that the new temp, right?
Yes, I was about to come to that, right? So yes, I'll now what you are doing is like you are going back to the last element, and this operation itself is taking big of n because you need to iterate through the last element. And now the suggestion, whatever suggested now, that is what is being done in a big of one operation. So what you either you can the second thing is that you can instead of having a head reference, you can keep a tail reference. The keeping tail reference, again, the problem is like if you want to delete the first reference, right? Again, or the just second last reference. So this reference, if you want to delete, again, this will take big of n operation. Instead of that, what you can do is in big of one operations, the suggestion, whatever suggested by my friend, right? So you can create a temp node. For example, this temp node here, you just created. And what you can do is head.next, you can point to this temp node, and temp.next is head.next.next. And these values you can just swap. You keep 10 here and move back 2 here. This is what you can do. And this will be like this temp pointer adjustment, and then swapping the values will take big of one operation. So this is how you can do big of one operation. I hope this is what you suggested.
Correct.
Yeah. So this is how it can be done, and this will take big of one operation. Again, deleting the head node, same thing. Like you can delete the head node. Deleting head node is a bit simpler because what you do is like not that simple, because again you need to take care of this pointer. Same thing you can do, like you can copy the element back, but that is not big of one here, right? Big of, how it will be big of n? Any guesses, guys? Deleting the head node, it will take big of one operation.
You have to copy all the elements. to the previous one.
Yeah, but that is a big of n, right? Because you need to traverse to the last node, and
Yeah,
then
that is what I'm telling.
yeah. But it is a big O. You can do in big of an operation. How you can do that?
By using a temp.
How you will use a temp? Let's say I created a temp here.
Okay, you'll create the temp
Hmm.
and you will, so you want to delete the head node, right? So you will just point to null and just and point, no, but
Copy copy from the second element to the first one, head. Copy from the heads next to the head.
Yeah,
yeah,
exactly,
yeah,
exactly. That is what.
Then
I
get rid of the next.
Exactly, exactly.
yeah.
So you need to delete this, right? Instead of deleting this, what you do, you copy 9 here, right? Because you know this pointer, right? You don't know this pointer here now, because to know this pointer, you need to reach next. But you can reach this. This is a simpler one. So you copy element and then you just adjust this pointer. Pointer to next dot next you do. This next node is anyway free now. So this is how you can do in big of an operation, right? Okay, moving next. Being asked how you detect a loop in a linked list. For example, right, in this case, if you see this list, right, where you can see that the last node is referencing to some intermediate, some node in the linked list. That is how it is being formed a loop. Now, let's see if I want to print all the elements in the linked list, right? So what we did, like we just tried like node.next is not equal to null, node equal to node.next. So what you're doing, you're looking for a node which is pointing to null, and then you are traversing. So this kind of loop will never terminate, because we don't have any null node here, node which is pointing to null here, right? Because the last node is pointing back to 6. You're traversing 2, 9, 6, 20, 99, 1, and then 1 again, 6, 99, 1. So it will be keep looping in, right? So this is the loop, right? How will you detect a loop in a linked list? How will you detect a loop in a linked list? There are different approaches, like a number of approaches we can go ahead. And many things will be asked by the examiners, like if you're trying one approach, then they will stop it. No, you don't do it in this way. Can this be done in a better way? Right. Once you suggest that solution, also they may say it can be done in still better way, right? So that kind of, there are so many algorithms are available. So let me cover a few of them right here. For example, like we have a node structure, you know, right? We have an item and then we have a next node. So what you can approach number one, right? What you can have is like you can take another Boolean element saying that visited, and that visited will be set to false. So once you start this, your detect loop in linked list approach, right? So you start reaching to all the nodes. So let's say in this node, you mark this as a detected, means visited equal to true. Go to next and mark this as visited equal to true. Go to 6, here. So mark this as a visited true. Go to 6, mark true. Go to 99, mark true. Go to 1, mark true. Once it comes back to 6, right, where you identify that it is already visited. So that means it is a loop, right? So let me cover that again. What we are doing, we are started with this particular element which is there in our node class. So what you are doing is you are slightly modifying your node class, and you are adding one Boolean variable saying that visited, okay, and that is by default set to false. Once you start, right, you start updating that value, Boolean value visited to true, okay, and keep checking that if the value is not visited to true, okay, and then keep marking that. Let me show you that code if I have. Okay, I don't have that code.
So what happens if there are duplicate elements?
What duplicate element?
Suppose we have 6 2 times. Instead of 1, we have 6. So we may have duplicate elements, right?
I'm not checking element here. I'm checking that field. You mean to say like this? You mean to say like this? Right?
See, the logic you are applying for Boolean values, basically you are checking the value it is containing, and you're marking it as true, like that. You're not checking the value, right?
I'm checking, right? I have to check the value. If it is not visited, then only I will mark it as a visited to true. If it is visited, means it is a loop. Whatever you suggested here, right? It is for the complete node, not only for the item. Item is not coming into picture here. Item, whatever it is, I'm not bothered. It is for the complete node. This class is referencing, this class is representing the complete node. This node, right? This is a 2, and then this is a next pointer, what I have right now. So I'm modifying these two values along with some other field called as visited, Boolean value visited, which is set to false now. So once you iterating, right, you keep marking that as a true, and until you just, but once you start, right, you are detecting a loop algorithm. You start with checking this value. If it is not visited, right, then once you visit, you mark is a true. Keep moving until you hit with the scenario where that element is marked, and you can iterate this until you hit with the null. Okay,
Right,
or
right.
the element is already visited.
So
Then
why
you can,
this solution is not a good solution? I mean,
yeah, I'll
if
come back to that.
interviewers, yeah.
I'll come back to that. Yeah, I'll come back to that. Okay, just let me explain to all the approaches, then I will tell you that you only can figure it out. Because why it is not a good solution? Okay, because you are modifying your node structure. Okay, it may happen that you are what you are doing is like you are extending your framework. Okay, where you are not, let's say you are not supposed to modify this node structure. How will you do it? Right, there should be some better solutions.
Also,
Whatever
this will
algorithm
only
you are
work
writing,
once.
yes, because you are modifying that only works once, not necessarily, because I can take a reference and I can modify it. I am not going to update that completely. I'm not going to pass that reference. Yeah, if you are if you say that let's see, like there are a few questions coming in the chat session. Like costly operation. Yeah, it is costly operation, because modifying node structure is not a good solution, because you should not be modify whatever existing things, right? That is the approach one. I hope this approach one is clear. Let's move to the next approach. Is that question clear?
Firoz,
Like,
this is O of 1.
sorry.
I have a question on the time complexity. This is O of 1, right?
No, this is big of n, right? Until you detecting a loop, because you have to iterate through the complete list. Whatever operation you do, right, it will be big of n only, because you have to iterate the complete loop, right? So what is the big of 1?
Yeah,
Big of 1 is a constant operation.
yeah, that's what. Yeah, big O of n. Yeah. This is n, or it might be a more than n, because B might be looping through, let's say, first element. Okay, that is the O of n in
Yeah,
most
big
of
of
the
n
cases.
plus
Yeah.
1, so we can ignore any constants. So it is big of n.
Yeah, I
This
understand.
looks to be pretty simple, because I have only 5 nodes. Let's see if I have 1000. Let's see approach 2. Approach 2 also works in a similar way. Like it also modifies not the node structure but the node pointers. So what I'm doing is, like in this approach, I will take a temp node, okay, and I will start iterating. For example, like let's say my current node is here, and what I will do, once I visited this node, right, I'll mark the next of it to this temp node. Similarly, I will visit that next node, in this case here, and mark this next to the again temp node. Again mark this to temp node. Again mark this to temp node. But I will check if node.next is not equal to temp. In this case also, what I will do, node.next is not equal to temp, right? I will mark this as a to temp node. Now once I come to here, I will check node.next is not equal to temp, right? But in this case, it is already pointing to temp node. Let me show you with some pictorically. So how it goes, right? Now I need to mark this next. So before marking, right, I will check if it is already pointing to temp. That means it is a loop, because I have already visited. So this is the same concept. Instead of modifying the structure, right, what you are doing, you are changing you are completely destroying the linked list here. So what I will do here is like current equal to next equal to null. So basically, if you have only single pointer, you return false. This only single node, so that is not a loop. So you are returning null, or returning false. Otherwise, what you do, you create a temp node, and current.next is not equal to null. Until you hit with the null, you keep changing the pointer current to current.next, and all pointers will be adjusted back, right? But in this case, there is one condition you are checking: current.next equal to temp. If current.next equal to temp means, here you saw it here, right? Once you point back this one, and current dot next equal to this. Earlier it was here, right? Its next is already pointing to the temp node. So that this is the place where you break the loop, and you detected that there is a loop, because what I'm doing here, right, with this next pointer, I'm just making sure that I have visited or not. So visited nodes, I'm making it to a point to a temp node. So that is what I'm doing here. Earlier I was modifying that data structure itself. now what I'm doing, I'm pointing that next node to the temp node. So to making sure that I have already visited. And once you detect that the node which I'm visiting again has already visited, so I mark this as a loop. So I hope it is clear, guys, because this is what I can try, and there is a code also. I written it so that it will be simpler for you guys. I will wait for a while if you want to go through this code, and if you're not clear, then I can explain the same thing again.
I think it's clear.
It's clear. I hope it is clear for all. Okay, let's move to the next. This solution will destroy or modify the linked list. This is just for a note, because you know, right, I'm just modifying the head references, all that things. I started with the header, so everything is getting destroyed here. Okay, approach 3. So what you can do is, like, you can take a hash set and keep adding the node, visited nodes, right, in a hash set. So hash set cannot take a duplicates, right? So before adding in a hash set, first check that hash set if that contains this particular node. For example, let's see, I started with I created a hash set. Okay, I created a hash set, and I inserted this particular node, a reference of this node. Okay, so this node 2 is added into this hash set, and then visited 9. I checked that whether 9 is already exist. No, so I added 9 here. So we visited 6, so you added node reference 6 here, right? And you, once you visited 19, right, you validate that if 99 is already exist. No means you add this 99 here, and you visited 1, you check 1 is already not exist in the linked list, you add this 1 also in the linked list, in the hash set, sorry, this one here. And again you go back to this 6, because next of 1 is 6 here, so you check already contains or not. So because this node is already contains, right, contains in the hash set, it will take unique values, right? Properties of hash set is that it takes a unique values. It has already contains this particular 6. So this is how you detected that it is a loop. It is a simpler operation, right? You are not destroying the loop, you are not modifying the existing data structure. It is pretty simple. So this is how you can do. You take a hash set, okay, and what you do, first check if it is contains this current node. All right, current is not equal to none. So I'm iterating to the complete. So what you do, you just keep adding into the this hash set and just iterate into the next element. Once you identify that, once from 2, once you again come back to 6, right, you this condition, right, you will get into true, and then it returns true. This is how you can do it in a simpler words. There is another, yeah, tell me.
Can you quickly repeat approach 2?
Approach 2.
Yeah.
You meant to say this approach? Sorry, this one. This
not this one, second one, not the Boolean one, second one.
Yeah, this one, right? Okay. So in approach 1, what we did was, right, like we in approach 1 and approach 2, what we are doing, we are trying to see if that no particular node is visited or not. All right. So in approach 2 also, what we do, visited or not. So whichever node we visited, right, their next pointer will change and we'll mark it to temp node. Okay. Let's say I will take a temp node here. Let's say this is a 0 temp node. And once I visited here, right, so this is the head and my current pointer is pointing here now. I will change it to current pointer, and this head reference I will mark to a temp node, because representing that I have already visited. Okay. Next, what I will do, I will change this current pointer to here. Okay. And I'll mark this next as a temp node, mentioning that I already visited 9. Next, I will go and mark this current pointer here. Okay. And its next pointer, next of this, to represent that it is already visited. Okay. Again, same. I will come to my current pointer moved here. Okay. And this pointer, whatever is there, right, I will mark to a 0 to represent that I have already visited. Okay. Now this, again, I will move to the current here, and I will mark this as a to a temp pointer, making sure that I have visited 1. So far I have visited 2, 9, 6, 99 and 1. Now you come to the 6. Okay. Now you move to the 99, again back to the 99, right? You cannot move back to the 99 because this next pointer you already destroyed, because this already pointing to a next node. You don't need to move back actually. Before moving only, right, you can check that current dot next is not equal to temp. If it is temp, you return it as a what? Loop, right? So that is what you are doing here. You don't need to mark. So this is how you can identify that it is already marked. So that is what I'm doing it here. So what I'm doing, I'm just changing the pointer and just loop or already marked ones. So that is what I'm doing, right? So once you identify, once you come to 6, right, you identify that it's next is already pointing to temp. That itself suggests that it is already visited node. Once I reach to 6, I will identify that okay, this is already visited node. It is a loop. So that is how it is. Approach 3 is much simpler one. You take a hash set and you keep adding the nodes into the hash set. Before adding the node, you just check whether that node already contains into that hash set. If it is contains, then that means that it is a loop. For example, in this case, you add 2, add 9, add 6, add 99, add 1. Once you go to 6, right, once you are trying to add, before adding, you just check whether set contains this particular 6. Yes, it contains. So it is a loop. So you return it as a loop detected one. Okay. Couple of questions coming in.
Firoz, it seems like this approach will take extra space, right? So space
Yes.
complexity will be O of n.
In all the cases, complexity will be big of n only, because we have, in a detecting a loop, right, you have to iterate through the complete loop. So complexity will be big of n.
No, I'm talking about the space complexity.
Yes, that is what I'm coming. So even this approach is not a good approach. We'll go to the next approach. Okay. So this approach, anyway, yes, you're right. It will take big of n extra auxiliary space, because you need to store this in a hash set. So hash set can be a maximum. It can take big of n values, because I can store the n nodes, right? So that is how it is. Complex one, not complex, like space complexity wise, it takes an extra space. So we'll see the next approach, which is supposed to be the best approach. That is what the examiners will be expecting from you. Okay. A couple of questions, guys. I'm not able to go back to all. If you can just let me read out if possible, like Saurav Gupta's slow pointer, fast pointer. Okay, I'll come back to it after I introduce resetting it. Big of 2n. See, guys, big of 2n is just 2 raised to n. I'm not getting exactly what is that question. If you have any particular question, please.
So that was for resetting. Like if you have to reset that.
Okay, fine.
For the first approach, so it
Okay,
becomes
fine.
2n.
Okay, fine. So next we'll move to the next approach, which is the best one, which is called the Floyd cycle detection algorithm. So what you do here is like you start with the slow and fast pointer. So you take a 2 references, slow and fast reference, and your slow reference will be moving one node at a time, and your fast reference will be moving to 2 nodes at a time. For example, let's see, slow to the 9 and fast will be, initially it was at 2, right? Now it moved to the 2 points, 2 nodes. So slow moved 1 node and fast moved to the 2 nodes. In the next iteration, slow will come to the here at 6 and fast will go to the 1, right? So it will be like this. So it has moved to the 2 nodes at a time. So the algorithms works in a way that at certain point, right, if you have a loop, right, this is a loop now. This is a loop. If you have a loop, in certain point, these 2 pointers will meet each other. For example, if you in the next iteration, right, slow will come to here and fast will move to the 2 points. It will come to 6 and 99. So they both meet at the same. So in a loop, right, if you are moving pointers by any speed, so they are expected to meet at certain place, right? So this is how this loop will be detected. These both pointers are meeting at the same point in this linked list, then it is considered to be a it is a loop. Okay, so that is what this algorithm works. It is pretty simple. It is not modifying your node structure. It is not modifying node next pointers. Neither it is taking any auxiliary space, right? it works perfectly fine with just 2 pointers, which is
What is the complexity of this?
it is big of n. So because maximum I have to go through the complete list.
Big of n.
Big of n.
N.
No,
Okay.
Yeah.
it can't be big of n, right? Because let's say it's a very big circle. Like instead of 6, 99, and 1, it's 6, 99, 1, 10, 20, 30, 40, 50, like 10, 1. So
Right.
to
Yeah.
meet
Right.
these two pointers, it will
That's
have
right.
to loop into circle like many times.
Yes, but this is my fast pointer, right? It is moving 2 points, but slow is still going very slowly. By the time it hits the last one, right? The last in the node, it may take some extra also, big of n plus some extra thing.
Yeah.
But if it is a big loop, even if it is a big loop also, this two pointer approaches works much better actually compared to other solutions. This time complexity, maybe somewhat more than that. It requires a mathematical formula because we don't know exactly
It can
how
be
long
also
it
less. It
Okay.
can also be less than n, right?
It may be because
For
let's
the
see.
example you have given now here, 1, 2, 3, three iterations we are getting it.
Yeah, but this is very simple one. But
There are
in
5
real life,
elements.
yeah, real life it will not be like that. So it will be more complicated things like, and loop will be very
What
bigger
about
loops.
what about if we move the fast pointer 3 at a time or 4 at a time? Can we do that?
You can do that, but again, that will be like more complex things. See, these two, why we are moving 2 places is like to make, not to make it faster, but make it simpler. And even you can try that actually. I have not tried that making 3 or 4, but this is what Floyd algorithm suggests, that making fast as a 2.2 nodes. But I have not gone into 3
In
and
that,
4.
in the other case, it may not be detected also. If you, it may not be easily detected.
Yeah,
It may take
will
more
it
time
will
if you
detect.
try to
Yeah,
do that from 2 to 3 or 4.
yeah, even in 2 also it may take some
That
time.
case
3
is
may
possible.
get detected faster. It depends like what how your loop is. It all depends like your 2, 3, 4, whatever you take, right? If it is if it is having loop, then they are supposed to meet at the same point, because that is what that algorithm, not algorithm, like it is just common sense, right? But what time they will meet, again it depends. Like for example, like I may have some, if you take one more extra node here, right? So then this loop will go 2 times. For example, like let's say this started with the fast here. My slow comes here, the fast is here, right? One slow is here, then my fast is here. When slow comes here, right? My fast will be this to this, it will be here. When slow comes here, right? Again the fast will here. So it takes little longer time. So again it may get into next iteration also, then this may take some more time as well. That is what the algorithm is. So code wise it's pretty simple. What you are doing, you are assigning to the head node both, means the current node slow and fast, and just checking that fast is not equal to null. Fast dot next, fast or current, it is the same because it is pointing this. Fast dot next is not equal to null because we are moving 2 pointers, right? So we just check that it is not null. Slow you move the one place, and fast you move to the 2 places, 2 nodes at a time, and then you check slow and fast are meeting at the same point. If they are meeting, just return true or just return false, because one of the condition will be false here. Either this is false because next node, if it is null here, right? So one of them will be true.
This has one problem, I feel. When you're saying fast dot next, you have not done a null check here. Okay,
Yeah,
fast dot next
right.
has to be,
Yeah,
because if there is no rule, this can have a null pointer exception.
yeah, that is fine because fast I'm checking here, right? Let's see this this got into fast dot next is not null. That is that I made it sure.
Achha, that is it. Yeah.
Right?
Okay.
Fast dot next is not null. Now let's say fast dot next is null. That is fine because I'm checking here, right? This one. Okay. That is what the approach for. It works out much better. It doesn't take doesn't modify any node data structure. Neither it modifies your next pointer, or it doesn't take any auxiliary space. It works much better. So, and this is what will be expected from the interviewers' point of view. They will ask this. But whenever you start answering, right, don't directly jump into this slow fast pointer. That is what I have seen people doing that. and once they've been asked to write this code, and they will mess up with this. My suggestion is that go with the hash set and let them figure it out. What is the problem in the hash set? If they ask you what is the problem, then you can mention that it is taking some auxiliary extra space. We can still avoid that, and then you jump to this, because that solution, if you code, if they ask you to write the code, right, it works pretty simple. Like you take a hash set and then just check add, and just before adding, you just check which is not contains in that hash set. Works much better. This Floyd cycle detection. But once you suggest this, right, once they ask you to write the code, people I have seen, like even the interviews which I take, when I ask them to write, they directly say, okay, fast, slow approach, and then drawing a paper nicely. They say, okay, it is working perfectly, all right, understood, write a code. They completely go wrong, as one of my friends suggested, like fast.next, not checking the null condition, all that things. A lot of things people will go wrong here. Okay, many people are from the C++ background, Java background, right? They sometimes get confused, passing with the head reference, passing with the current references, and then things will go wrong. People will be panicked and things may go wrong. My take on this to first go with the approach 3. If they come back with some additional question, if interview is smart enough, and if he figures out that it is taking extra auxiliary space, then he may ask what all the problems, and then you explain that it's taking auxiliary space, then how you can avoid it, then you come back to this. That is what I can suggest.
There's another problem with approach theory, right? If you have overridden equals method to check the value, then it won't work, right? If there's a duplicate element in the linked list.
Duplicate element? No, I'm storing with the node, right?
Reference.
I'm storing with the
references.
reference. Yeah, that's nothing but reference in the heap. That cannot be.
Okay.
The only thing
Not
is
the
if the equals method of node is overridden. That's the question.
If someone has overridden it,
nodes method. Okay. Then you may have to take that hashing. You may have to do hashing, and that time things may get a bit complicated. That is also one of the problem. But usually people will not. I believe that will not override and do such mistakes. Okay.
Question,
The last
one.
question. Yeah, tell me.
On the slow fast, is it? Do we know that? Where do we? Can we ascertain that slow fast is always at the per second node in a loop, or it can be anywhere based on the?
It can be anywhere. It can be anywhere. So that is what I was explaining. Like, for example, let's see. It can be anywhere, right? Because you don't know like where they can meet.
Okay.
So, because it is going to pointer fast. Let's see. I will take one more example. Let's see one.
Like just extending this use case, right? Detecting is okay, but if they say that delete that loop, then
I will come to that question. That is the next thing. Let's see, for example, this one. Okay.
Yeah.
So you started with fast, slow here. So you moved fast, slow here, and fast here. Slow came here and fast moved back here. Slow came here, your fast is here. Let's say this is a loop, right? Next, what you do, your fast is here, your fast moved back to here by the time your slow is here, right?
Correct.
And next your fast moved to this place and your slow is still here.
Correct.
Right? Now both slow and fast are meeting here. Right?
Okay.
So in this case, you are meeting at the first node. So let me cover that. I will show you like how you can detect the loop and break the loop. This is what the next. So detect a loop and you need to remove a loop. So remove a loop means you cannot cut back any intermediate pointer. You need to cut back a pointer reference where the loop has just begun. For example, here in this case here, right, the 1 is pointing back to 6. So this need to be cut back to pointing to a null. So it should be something like this. So how will you do that? I think that was the question being asked. So what you can do is you can use the same slow fast approach. Okay. In this case, what you can do, right? The algorithm believes that once you identify a point where the slow fast both are meeting, and then from that point you go one position each. Let me show you the code. It will be more clear. So I hope I explained what you need to do. what you need to do is like, you need to identify a loop. First you detect a loop. So using slow pointer, I detected a loop. So loop is coming here. Next, what you do, right? You move your slow pointer back to the head reference. So you moved back to the head reference and then use the same approach, same algorithm in a slightly different way. Now the slow, fast, both are moving in the same speed. Okay, not the fast is not moving to a double speed. It is moving in the same speed, means it is also moving the next, only one node. So it is something like that, right? In the next iteration. Next iteration, it will be like that. Sorry, next iteration, your slow, fast, both will be at this place, right? It will come here. So this is the beginning of the loop. So this is how the algorithm identifies the beginning. I hope I cleared. It is clear, guys. So what I did was, first I detected the loop. So that node 99, right? The loop detection happened. So once the loop detection happened, right? What you do, you move the slow pointer back to the head reference. Head reference anyway, you know, right? Because I have not modified the head reference. Head reference is at the 2. So you moved back to the 2. Now what you do, you move both the pointer in a similar speed now, okay, to identify what is the first node in the loop. Okay, so what I did was, I just moved, and here in the place of 6, right, they both are meeting. So once you identify that fast dot next is slow pointer itself, so that means slow has also reached to a place where my fast dot next is going to move, right? So in this case, so I did just a mistake, like I just added forgot adding one more slide here. So here what you are doing, maybe code, if you see, it will be more clear. So slow will be moving to the 6th place, and fast will be, again, it is supposed to move, but just before moving it will check if it is fast dot next is slow pointer itself, slow reference itself. If that is the case, then I will mark the fast dot next to a null. So that is what I have done. So if I have moved this algorithm in that way, right, both could have met again back to same place. This is the beginning of the loop, right? This is the beginning of the loop. So that is what they are meeting again. So that is what that algorithm believes. So once you detected the loop and you move back the slow pointer back to the head reference, and fast pointer you move in the same speed both, right? They move again, they meet again in the same point, where that is the point where the loop has begun. I hope it is clear, guys.
So will they satisfy for all cases?
Yes, they satisfy for all cases. That is what
more elements
yes,
before the loop or inside the loop. If you have more elements,
yeah, you can verify that. You can verify that. You can take any number of elements and verify this approach. Once you detect the loop, right? Once you detect the loop, move back that slow pointer back to the head reference where the loop has already begun, right? Where that linked list has begun, and then you start that moving to a same speed, one node at a time, and then they again meet at a point where both nodes are considered to be, you know, pointing to the same reference where the loop has begun. So loop has begun from the 6. So where the loop is begun, right, that earlier node you need to mark it to a null. So what I'm doing here, right, fast, instead of moving back to 6, what I will do, I will mark that as a null, because my next is nothing but where slow has already moved. So if you see the code, right, it will be more clear. So what I will do, both are pointing to a slow and fast pointing to a current node, which is the head reference. Let's see. Now with this case, right, I have detected the loop. So I moved the same positions here, next position, and then I detected a loop. So now I'm here. Here I detected a loop. Once I detect loop, what I will do, I will move back my slow pointer to the current. So this is what the head reference. Okay, I moved back to the slow pointer, and now what I will do, I will just check this condition. Fast dot next is not equal to slow dot next. So this is what I'm checking. This fast dot next, right? Fast dot next is not equal to slow dot next. I'm checking. In this case, it is, right? But that is what I will check for all other cases. And what I will do, I will move this pointer by one reference. Slow dot next and fast dot. So I will move one position. And once you hit with this condition, right? You hit with this condition, fast dot next is not equal to slow dot next. Okay. So once this condition is false, so that means fast dot next is equal to slow dot next. So what you do, fast dot next, you mark it as a null. So that is what I'm marking this as a null here.
Cool.
This is how this algorithm works.
That's this will, yeah. Question for us, will it also detect and remove multiple loops if they are, or? How is that? This approach?
I don't think so. It will detect multiple loops. Multiple loops, that becomes more complicated. I have not tried, guys, but I don't think it will work for multiple.
Okay. Yeah. But
I
yeah,
don't
thanks
think
for the explanation.
a similar linked list can't be having a multiple loops and
Yeah, we can
cannot
have multiple loops also.
Right. That's
cannot have.
Yeah, because there is only
Okay.
one pointer, right? We can have only one loop.
Correct.
Multiple
Yeah.
loops means what I understood was something like this. Let me correct that. What I understood was like okay, where it was. One minute. Yeah, this is a circular list. Yeah. Let's see. Yeah, we cannot have it, right? Yeah, we cannot have it.
Correct. Yeah,
There
you
will
cannot
be
have it, I
only
think.
one next pointer, so we cannot have
One
multiple.
next pointer. Yeah, correct. Yeah.
Yep. So I have written some code here, like for doubly linked list, and this is for singly linked list, and I have given some references also, like approach 1, 2, 3. All I have discussed here. Reverse single linked list, I think I have not covered. The code is there, you can go through it. Without having head reference, how will you delete? I think this you need a while loop here. And then detecting what is this? Detect a loop. So this is approach 1, then approach 2 is there, approach 3 is there. All the approaches are in this wide algorithm. I have written the code. And detect and remove a loop, circular, create circular linkage. All these things are there. So this code I have attached here. You can go through it, and these slides will also be uploaded on our channel as well. So any other questions here? Guys, any questions before I stop the recording? Let me
So is there a chance that it won't work? Because now that after we have detected this loop, right, then we are only moving both the pointers by one. So if these pointers are in such a way that they keep sliding and they never meet, is there a chance?
no,
Because
it is
previously we were doing twice, right? So they has to meet, or they has to meet
they
at
will
one
meet,
place.
because what we are doing, right? See, we have only one linked list, one list. So this is the one list, right? Once you move back this low pointer to start, right? And again you are going back to the last. Before hitting to the last only, you will meet, both will meet, and that will be the beginning of the loop. There is a mathematical formula actually. If you just Google, I have not covered that. I have not gone through it.
Can you show the code? Can you show the code for this? Removing
code
loop.
for this? Code for this.
Yeah.
Yeah.
Maybe from my understanding, we may have to. I mean, in our example, we got it in one iteration itself before we do it. But yeah, but in another cases, we may have to reiterate that looping construct more number of times. But we'll finally hit common node where it starts.
That's what I was thinking. But since we are moving both the pointers by one speed now, so if that comes into picture when we are just looping, then that would never work, right?
No, but
Because,
at some point we will meet. That's what they're saying.
No, they meet. They meet at the same point.
Yeah. Maybe it will take in some cases multiple iterations, so number of iterations may increase, but it will meet at a point with this one next approach at the point where it loop is starting. Probably
I
we have
think
to
what
try
I
out.
suggest is like you just try it with some examples or setting with the pen and try with that.
Can you try a dry run of 1, 2, 3, 4, 5, 6, 7, 7 elements, 5 to 7 it's loop.
1, 2, writing here is horrible. Let me try. 3.
Just try once for me.
Okay. 4.
1, 2, 3, 4, 5, 6, 7, 5 to 7 it is a loop.
6 and 7. Okay.
Loop is between 5 to 7.
1 minute. So loop is between 5 to 7. So you mean to say loop is like this, right?
Yes.
Am I right?
Yes.
Okay. So you started slope fast from here. Both are pointing here. your slow is here, your fast is here, your slow is here, your fast is here, your slow is here, your fast is here. When your slow is here, your fast is here. Okay. So they are meeting at the same point here.
Sorry, once again.
Your
They were straight thing.
you start, let me cover again. Your slow, fast both are here, right?
Yeah.
More slow here, your fast is here.
First is here.
Once
Yeah.
you're slow here, your fast is here. You're
Yes.
slow here, your fast is here.
Yes.
Slow and fast both are meeting at this point, right?
Oh, first now comes here, no? The middle element.
Here, let me see.
Yeah, fast comes at middle.
Middle
Fast,
element.
fast comes here. Okay, fine.
Middle.
Fine. So your fast comes here. Let me try that again. Slow is here, fast is here, slow is here, fast is here, slow is here, fast is here. Okay, sorry, fast is here. No, they are meeting. Yeah, right. Fast is here. So when slow is here, fast is here, right? And both are meeting. Okay, both are meeting at this point.
Last
Right?
element. Right, right. Correct.
So once they are meeting, so what you do, right? Your slow pointer, you are moving back to here.
Right.
Again, your slow pointer is here.
Right.
And now what you are doing, you are moving one pointer, right? So your slow comes here, your fast is here, right? Your slow comes here, your fast is here. Your slow comes here, your fast is here, and both are meeting again back here.
Okay, got it.
So it works actually. This is the algorithm. Not I have given it, it's Floyd algorithm.
Okay, fine.
Much
Yeah, there must be some mathematical equation which proves
yes,
this.
there is a
like,
mathematical equation that I was trying to explain, which I have not
because
gone
it
through.
seems like it might not work in if there's a gap, but we'll have to check that algorithm.
Oh,
Yeah,
yeah,
you can
it
just
works.
take a pen and paper and work out with some like this kind of cases 7, 8, 9, 10 or whatever you want to work it out. But it works. It works. This algorithm is being used in many OS related calls. So yeah, and some code snippets I have attached. This linked list and DoubleLinkedList. This linked list has a circular list also. That's it, guys. If you have any questions, let me stop recording.
So in the link
Satish, you need to
that
stop
you
the recording.
in the link you shared, we have all the codes and all, whatever you explained.
Not all. Like I have written many codes here. Not all. I don't have all, but majority of them I have written. Like insert beginning, delete first, insert last, delete node. This will take. It can be anywhere. I think this scenario I have not covered, but it takes. Then visiting the node, printing a node, finding a middle element. How you do? I think I have covered a lot of reverse linked list. I have not covered, right? But the code is available.
So those are Git links or how is it?
The slides will I will be sharing, and you get this code. You just import in Eclipse, remove this package. It works fine. Yeah, that's it from my side. Any other questions? Satish, you need to stop the recording.